3.1 Notes, Functions and Function Notation, page 7. So the previous page talked a little bit about the vertical line test. And so example 15 up here, and let's use a different color, asks us to use the vertical line test following our functions. So the vertical line test says that each x must have only one y. And as we draw a vertical line, what I'm doing is saying, hey, here at x equal 2, how many y's do I have? At x equal negative 1/2, how many y's? So any place I draw a vertical line here, it's only going to cross my graph once. So yes, this is a function. For B, if I draw a line here, notice that it hits twice. I already know that, no, that's not a function. But here's the question. What if I draw the vertical line right here? And so it only hits that circle in one spot. Does that mean this is a function now? And the answer there is no. You've got to be able to draw that vertical line anywhere and have it only hit once. So this one is not a function. I'm going to try to color code because down below, we're going to use a horizontal line test to determine if something is one-to-one. So right here, only hits once. You don't always have to draw more than one. Oops, that's not what I wanted to do. So this one's a yes. Is a function. And this one right here, you will notice that red dotted line in the middle, because that's our asymptote there, not part of the function. So yes, this one is a function. Here looks like a cubic. I mean, we really don't need to draw. That one's a yes. I draw this here and it hits twice. So that is a no. And you could always pause and not listen to me yak on and go through these and come back and double check. For G, oops. It's only going to cross once. And then for a line, it's only going to cross once. So I've got a yes here, and I've got a yes here. In every case where there is a yes, that X that I'm drawing that vertical line through is paired with only one Y. So now we're going to go to the bottom here. I'll choose lavender. We are going to use a horizontal line test to determine if these functions are one-to-one. So remember that one-to-one means each X gives us only one Y. Each Y gives us only one X. So it's got to go both ways. So here's the thing. If it's going to be a one-to-one function, it's already got to be a function. So I am not really worried about the ones that I've already written no on. But let's take a look at the ones where we've got a yes. So if I draw a horizontal line here, I hit actually 3 times. So yes, this is a function, but no, it's not one-to-one. And since mathematicians are inherently lazy and we don't like writing one-to-one out all the time, you're going to see it this way. 1-1, one-to-one. B is not a function, so it can't be a one-to-one function. C. If I draw a line right here, it only crosses once. But if I draw my line right here, it's going to cross infinitely many times. So no, this one is not one-to-one. And let's take a look at our reciprocal function on D. If I draw this one here, it only crosses once, remembering that that red dotted line is not part of our function. So yes, this one is 1-to-1. Let's take a look at E. Horizontal line here, only crosses once. Horizontal line here, only crosses once. So F is not a function, so it cannot be a 1-to-1 function. G is going to cause a problem for us. I'm just going to put it right here. We hit multiple times, and it looks like as that graph extends on, it's going to keep crossing the x-axis. So this one is not 1-to-1. And then H, our straight line, yeah, it doesn't double back on itself anywhere. So this one is also a yes. Okay, page 8. There is really nothing to go over. It is a toolkit. It's got pictures of all of the common functions. You want to make sure that you are comfortable with those, or sorry, common relations. You want to make sure you know which ones are functions, which ones are not, which ones are 1-to-1, and which ones are not.